Okay. So I need to determine my, let's write it here in black. I need to determine my endpoints. I need to determine where f prime of x does not exist. And I need to determine where f prime of x equals 0. So how about if we start by finding what is f prime of x? Oh boy. Take a look at that carefully here. What do you see? Grace, what do you see in this function here that's going to enable us to determine the derivative?
I'm not sure what you mean, like a specific element of the first.
Well, I mean, so tell me, just how are you going to find the derivative of this? What are you going to do?
Maybe, I'm not sure if it's chain rule or if it's like the multiplication. I'm not really sure.
Well, take a venture a guess.
Maybe chain rule. I'm really not sure.
Okay. All right. There is a product here, right? So one way to find the derivative here is to use the product rule. I'm going to have u v. Is everybody okay with that? Yeah, but there's an easier way to do this one. I don't want to use the product rule. I want an easier way to find the derivative. Any ideas? I'll take a volunteer. Any ideas? I want to use. Product rule. I'm sick of the product rule. I don't want to use it. I'll use product in my hair, but I won't use product in my calculus. I never understood why you guys talk about product. Like, what is that supposed to mean? Product in your hair? What is that like? What is that about? Why? I mean, where did that? Why isn't it just called like hair gel or something? Why is it called product?
I think it's because we end up putting more than just one type of thing in our hair.
Oh, so product is like kind of plural. Oh, okay. Well, now thank you for that clarification. I could never really understand it. All right, so I want an easier way. Any ideas? No ideas? Hey, guess what? I am going to distribute x to the 2/3 into this binomial. So I'm going to get, this would make this then x to the 5/3, because x to the 2/3 times x to the first, plus 2x to the 2/3. That's not f prime of x, that's just f of x. I'm not finding the derivative yet. I'm changing f of x to be that. So now I don't have to use the product rule. Now I can go f prime of x is equal to, that would be 5/3 x to the 2/3, right? 5/3 x to the 2/3. Yeah, that's right. Plus 4/3 x to the negative 1/3. Does that work for you? Yeah, Zian, please.
How did you get x to the 5/3 and 2x to 2/3?
Yeah, so I am distributing x to the 2/3 into this binomial. Okay, so I have x to the 2/3 times x, right? but this is actually the same thing as x to the 3/3. So when you're multiplying with the same base, you add the exponents, right? So that's how I got x to the 5/3. Are you sure? That work? And then the other one, I just multiplied 2 times x to the 2/3, so 2x to the 2/3. Pretty good. Okay, so this is my derivative. Let's erase that. Okay. Well, I think before I continue, I'm gonna test it. I want to make sure that I did it right. So get rid of that. I'll leave that. Let's make this a smaller screen. Okay. So my f of x equals x to the 2/3 power times x plus 2. Whoa, look at that. That's a pretty neat graph. Kind of does a little bouncy thing there. That's cool. I like that. And I'm going to find my derivative. Let's call it h of x. And that's going to equal what I wrote there. So it equals 5/3 x to the 2/3 power plus 4/3 x to the negative 1/3 power. Ooh, wow, look at that derivative. Let's get rid of the function here. Look at that derivative. That's really exciting. Let's see if that's the right derivative. Oh, they're both green. What's that all about? That's not supposed to happen. Can't have both green. Let's call that, make that one purple. Yep, I think my derivative is correct. Everybody good with it? Yes? Okay, good. Well, see, I'm on the right track. So I'm feeling positive here. Let's see, this class is over at 10:40. Okay, so we're still doing okay. I think we're doing all right. Are you hanging in there with me? There's a lot of stuff today. You doing okay? Kind of. Okay, all right. I'm gonna continue then. All right, so domain of the function. Okay, that's good. So let's look at the domain of the function here. Magical. We're going to ask Maitland again. You see any denominators in this function?
Nope.
I don't either. I don't see any denominators at all. How about any radical signs?
No.
Well, I'm just gonna caution you here, okay? If I have a fractional exponent that can be written as a radical sign, right? This x to the 2/3 can be written as x squared to the 3rd root. Do you see what I'm saying?
Mm-hmm.
Everybody see what I'm saying here? So you got to be careful. But Maitland, does that radical sign have an even index?
No.
So this is the index. This is the radical sign. And the x squared is the radicand, radicand. This is the index. Is the index an even number or an odd number?
Odd number.
Odd number. So I don't care about that. I only care when the index is an even number. So that's not going to cause me a problem. There we go. So again, I'm doing don't ride lions, dear. Maitland, do you see any logarithms in here?
Mm-mm.
I don't either. How about have I defined the domain any place? If I said I only want the domain to be here to there?
No.
I have not. When you define the domain, it would usually say like a comma, you know, like x, you know, greater than 2 or something like that. You know, I would be defining it, but I'm not defining it. I'm leaving it as whatever it is for the function. So if no denominators with an even index, no denominators in the function, no radical signs, no logarithms, I didn't define it, what's the domain?
All real numbers.
All real numbers is the domain. Pretty good? I like that. I like that. All real numbers is the domain. Domain of my function. Let's write it here in green because my function is in green. Domain is negative infinity to positive infinity. All right, well, while we're doing domain, let's do the domain of the derivative. Let's see what the domain of the derivative is. Right? So somebody else gets to help me here. Lana, you're getting the hard questions today, Lana. All right. Do you see any denominators here?
No.
But see, you're wrong.
Yeah.
Oh, where is the denominator?
Because it's a negative exponent.
That's exactly right. Negative exponent. Okay. So let's rewrite our derivative here just for the heck of it, so we can see it a little bit more clearly. I have f prime of x is equal to, I'm going to call this 5/3 x to the 2/3 plus, and I'm going to write this a little bit differently, 4 divided by 3x to the 1/3. Are there any questions how I got from here to here? Are you sure everybody's okay with that? Z, you okay with it? I saw your hand. Maybe it's just your pencil going. Okay, right. So, Lana, I do have a I do have a cough, but it's improving. You might not believe it, but it is. I do have a denominator with a variable in it. So what do I need to do with that? Karina, who is not here, but I hope you're listening, Karina. Nikki, what do I do with that? I think maybe Nikki had to take off for a minute. Are you there?
Yeah, my power went out, so it's been kind of like off and on. It's kicking me out.
Oh, okay. Should I ask the question again? Or are you good?
Yeah, can you ask the question again?
Yeah. So so Lana tells me I have a denominator in this derivative right here because I'm finding the domain of the derivative, and it's this x to the negative 1/3, and we rewrote this so we can see that there's a denominator. What do I need to do now to find out, to help me find the domain of the derivative here?
You find where it does not equal 0.
That's right. So 3x to the 1/3 cannot equal 0. Well, if I kind of follow that along, I divide both sides by 3, I get x to the 1/3 cannot equal 0 because I'm just dividing 3 into 0, and I get and now I'm going to cube both sides, and I get x cannot equal 0. Yep, that's what it says. Okay, x cannot equal 0. So 0 is not in the domain of my derivative. Is everybody okay with what I just said there? 0 is not in the domain of my derivative. All right, are you sure? We're good? Okay, all right. So that was a denominator. I'm looking back at my derivative. Victoria, do you see any radical signs in my derivative?
No.
Oh, but remember, a fractional exponent is a radical sign. Okay, so really, if I wrote this with radical signs, this would look like 5/3 cube root of x squared plus 4/3 cube root of x. Really, stop me if that's not clear. I really want this to be clear. Are we okay with that? Everybody? Okay, so I have a radical sign, but Victoria, does it have an even index?
No.
No, so I'm not concerned about it. Not going to affect my domain at all. Okay, so Victoria, I'll give you the easy one. Any logarithms here?
No.
I don't see any logarithms in, and I haven't defined it either. Okay, so the only thing that is excluded from the domain of the derivative, so we'll write that in red, the domain of the derivative is -infinity to 0 union 0 to infinity. Are we okay with that? Yes? Okay, now, how many people want to stop here and finish on Monday or Tuesday? How many people want to keep going? I'm not seeing anybody that wants to keep going. I'm not surprised because you guys, there's a lot of stuff we just crammed into your brain here. All right. So somebody has to remind me to record the end of this problem when we do it on Monday. Okay. So we've got the domain of this function. We've got the derivative of the function. We got the domain of both the function and the derivative. We don't have any endpoints because so we're yeah, okay, so we're just going to stop right there. All right, and then we'll pick it up on Tuesday. Don't come to school on Monday. All right, ladies, that was brutal, but you